Hi, Alan Stratton from Wood Turns. Recently returned from the AAW Symposium in Portland. One of the demonstrators was Eli Avisera, whom I had not seen demo for quite some time, so I paid attention. So it's a good review, but he turned some small scoops. It's one of these things that he makes look very, very easy, but to do it, it's at a single piece and multi-axis, but to do it, he wrapped, for the bowl turning, this in a piece that then compressed it in a chuck. I decided I need to do something a little differently, or that I could, so since I can 3D print things, I did. And instead of making that, I'd used this that fits into my chuck. It accepts a dovetail. So it's the same concept of what he used, but then I thought that worked pretty good. Another difference from him is that he would have to clean up a nub here left on the end. And why not just extend the octagon method and go ahead and go clear around the sphere that's on the end of the stick. Therefore the end is finished. But then in order to do that, I said, well, how about a cup center? So instead of sanding that off later by hand, I put this on my live center as a cup center, drove it in, and I was not sure it would work, but it did work. So I think a cup center can work in the future on that. Another difference, I used the octagon method because Eli has done probably thousands of spheres, and he can do it by eye. Most of us cannot, inclusive. So let's turn a little scoop eccentrically.
This is 1.5 inches by 1.5 inches by about 5 inches. It is mounted between centers for a last trim before cutting a tenon on one end. This differs from the AAW demonstration, but this is so that I can finish turning a spear on the end of the spindle instead of carving or sanding the last nub off. More on that later. With the wood reversed, I can trim the end square, then measure the diameter so that I can lay out the key measures following the octagon process. The octagon contains the sphere that I want to see. Then do the two simple calculations, 0.293 times the diameter for a distance from the corner of the cylinder to the corner of the octagon, and 0.414 times the diameter for the length of each side in the octagon sides. Then trim the end opposite the corner mark down to a diameter equal to the octagon side. Now mark these measures on the side of the cylinder. Another video explains this in detail. After marking the near end of the octagon, proceed to cut an octagon side near the end, but only approximate the opposite side. Since the sphere is on the end of the spindle, I cannot cut it exactly, but I maintain the 45-degree angle for as deep as I can, allowing for the scoop handle. With a few more divisions as guide, I could round off the sphere by eye. It is pretty close, and much closer than I could have turned by eye only. When hollowed, a scoop would show off any out-of-round conditions. Then sand. In this project, I cannot refine the sphere using cup chucks. Since I had it handy, I grabbed my printed cup chuck. Pressed against the sphere, it shows remaining variations. Now for the eccentric part of this scoop project. I return the drive center to the spindle, but instead of a live center, I put a cup center on a threaded live center. However, instead of being centered on the drive side, I offset the end by about 3/8 inch, taking care to observe the best direction given the grain pattern on the scoop bowl. Then proceed to cut a cove a little distance from the wood bowl portion. This is cutting a lot of air until the cove depth approaches the opposite side and solid wood. How deep to cut? Well, that is a good question that has to be answered right now and by eye. Then sand up through the grits. Last chance to easily sand this section. No sanding in demonstrations, but I'll show it here since you will not be exposed to the dust. Finishing this section with shellac is also a timely idea. Now return the drive center to the original axis. This is so I can trim near the bowl. Sanding and finishing here is still a great idea. Then trim the opposite end and, you guessed it, sand and finish as much as I can. There will be a small nub on the end, but trim it down to a bare minimum. Now to hollow the scoop bowl. Eli Avisera had returned and reused a plastic piece that cupped the bowl in the chuck jaws. Mine is 3D printed. Either works. Leaving off one jaw allows room for a flat scoop. After flattening the top of the bowl, I proceed to rough hollow with a spindle gouge, then refine with a round nose scraper. The missing jaw also allows room to measure the wall thickness, since no one wants an eccentric funnel. Sand and finish here now also. The last thing to do is to mount a sanding pad and sand off the last of the nub on the handle end. This completes my eccentric scoop. After seeing a demo, I like to do it myself to hammer home any concepts, new or old. If I can, I like to enhance it or adapt the project to my tools, jigs, and capabilities. But this completes my eccentric scoop. Please give this video a thumbs up and subscribe to my website as well as on YouTube. Please spread the word by telling your friends about my weekly videos. I appreciate your comments and questions. Please wear your full face shield whenever the lathe is running. Yeah, I nag, but I hope to save your life.